So we left off last time. We had been talking about how to write negative binary numbers. And remember, the reason why we want to write a negative binary number is so we can use the addition algorithm to subtract numbers. So for instance, let's say we have x minus y. I'm going to change this to black pen. So we have x minus y. We can say x plus negative y is the same thing. And so we can use the addition algorithm, but we need a way to represent a negative number in order to use that addition algorithm. So we've already talked about this, what's called the signed magnitude representation, and we talked about the ones complement, and now we want to talk about the twos complement. So the twos complement is another way to represent negative binary numbers. And so the way that we put something into twos complement is, first of all, we invert the bits. And so basically this gives ones complement, because if you remember with ones complement, all we do is invert the bits. So we invert the bits, but then twos complement has one more step. Now we add 1 to the result. So what I'm going to do is show you how to put a few numbers into ones complement. So for instance, let's write -1. So to write -1, first of all, we write the number for 1, which is 0001. So this is 0001 is the binary number for 1. Then we're going to do step 1, which is invert the bits. So we're going to have 1110. Now what we want to do is add 1 to this result. So if we add 1 plus, this is 1, 1, 1, 1. So this is equal to -1. And you can see on this chart, -1 is right here. So -1 is equal to 1, 1, 1, 1. All right, let's do another one. So let's put 3 in let's write -3 using twos complement. So the first thing we're going to do is write 3. So this is 0011. We're going to invert the bits. So this is 1100. And then we're going to add 1 to that result. So this is 1011. And this is equal to -3. So if we look at this chart, -3 is 1101. So the advantages of this are, first of all, we can determine the sign of the number by looking at the most significant bit. So if we look at all of these, if we look at the most significant bit for all of the positive numbers, it's equal to 0. And so remember, 0 is used to represent a positive number. If we look at the most significant bit of all of the negative numbers, it's equal to 1. So 1 is used to represent a negative number. So we can tell if our number is positive here or negative here. Well, really this whole thing. So negative or positive by looking at the most significant bit. Another advantage of twos complement is that there's only one bit pattern for 0. So if we look at this, 0 is represented by 0000, and there's not a -0. So remember, for some of the other bit patterns that we use to represent negative numbers, we would end up with a 0 and a -0. Well, these are the same thing, so this is basically wasting one of the bit patterns that we could use to represent a different number. The main good thing, or the main benefit of twos complement, is that we can use the addition operation for subtraction. So let's look at an example of that. I'm gonna erase a few things just so we have a space. So let's do 7 minus 2. So 7 minus 2, first of all, I'm going to write down first of all, let's rewrite this equation. So we can use the addition algorithm by saying this is 7 minus 2 is equal to 7 plus -2. So now I'm going to write the binary number for 7, which is 0, 1, 1, 1, if I take it off this chart. And I'm going to write the binary number for -2, which is this 1, 1, 1, 0. So I'm going to add these together, and I get 1, and 1 is 1, 0, 3 1s is 1, 1, and 1, 1 is 1, 0. So I get the bit pattern 0, 1, 0, 1, and this is equal to 5. And that's what we expect because 7 minus 2 is 5. So let's do another one. Let's do 6 minus 3. So this can be rewritten as 6 plus -3. And so now what I'm going to do is write the binary number for 6. So this is 0, 1, 1, 0. And -3 is 1, 1, 0, 1. And I just pulled these off this chart. If you didn't have this chart, you could figure out what these are. We're going to talk later we're going to learn later how to figure out what your binary number is from a decimal number. But if you know the binary number, let's say you knew the binary number for 3, you could figure out -3 with 2's complement by using this method here. So invert the bits and add 1 to the result. So if you didn't have the chart, you could still get these numbers. So let's go ahead and add these together. Remember, this is equal to 6, and this is equal to -3. So we should end up with 3. So I get 1, 1, this is 1, 0, and 1, 0. So I end up with 0, 0, 1, 1, which is equal to 3. So that's this one. So the only disadvantage of 2's complement is that we can't determine if the number is larger or smaller based on the bit pattern alone. So if we just eyeball these numbers, like let's say we look at the bit pattern for -8 and -7, just eyeballing this, it's hard to tell which number is larger or smaller. Or like let's say we have -8 and 4. Although with this you have, that's positive and that's negative. So, but the disadvantage with this is that it's hard to determine your bit pattern. It's hard to determine the relative size of your numbers by just looking at the binary numbers.